Hi folks, this is part 2 of the digital logic simulator, and in this video we are actually going to learn about the D-level sensitive latch that we also discussed in my digital electronics lecture series in lecture number 16 and 17 when we covered latches and flip-flops. And in addition to that, we are basically going to create the D-level sensitive latch that you see on the screen using digital logic simulator, and it's a good way to learn and implement and then verify the logic. So now if you remember, I'm actually going to run the simulation here first, and D-level sensitive latch is basically a combination of basic SR latch using NOR gates that you see on the right side of the screen, and also it is a combination of basic SR latch using NOR gate and the level sensitive SR latch, and then the D input, which is basically a data line connected to both S and R, where the input data goes through an inverter, which would mean that S and R cannot be same at the same time. So if S is 0, R is going to be 1 because of the inverter that is connected to the input data line. The advantage of doing that is that way we are able to eliminate the forbidden state. Remember, when S and R both are high, your Q equals Q naught, and that is not possible because it basically violates the Boolean algebra laws and rules. Okay, so the simple thing that we learned from D-level sensitive latch is whenever you enable is high, so I'm going to turn it on, enable is high, your Q is going to be whatever the input D is. So if you notice Q here, the red LED is on, and that's because my input is set to logic 1 D. Okay, so say if I change the logic to D to 0, we would expect the LED to go off, and that's what happened. And then because Q is 0, so Qn goes to 1, so LED 1 is light up. Okay, so that's the basic function of the D-level sensitive latch, very widely used. Now let's go ahead and actually create something very similar. And so remember, I need 2 LEDs, 2 NOR gates, 2 AND gates. I need 2 switches, one for the enable, one for the input data line D, and then 1 inverter. So let's get going. Okay, now I got all my circuit components in there. I'm just going to wire them up. Remember, in order for you to wire, is all you need to do is you hold on to this node right here and then drag it and attach it to whichever input you wanted to feed your signal to. All right, so I'm gonna undo this, and I'm gonna use blue for my input D. So one of the ways to change the color of the wire is you go to here to the top right, click on this wire looking thing, and then choose the color blue, and then I'm going to so this is going to be connected to one of the inputs of the gate. Okay, this is the enable, so enable goes to both inputs. Okay, again, if you choose to go with a different wire for a clock, you can also do that. I'm now going to label all my important inputs and outputs. So this is being my Q naught, so I'm gonna label it as actually this is going to be Q here. Okay, I'm going to change the color of the LED. Actually, let it be yellow. Okay, there's my Q. This is going to be my QN, Q naught. So QN would be Q naught. Okay. I'm also going to use the labels. So if I go to gates here and then just hold on to label and then put it over here. So say this is my S right here. Okay. So just hold on to this blue gear and then it should let you. So this is my S. You can also change the size of the font. I think the highest you can get is 34. Okay. Go with 30. And you can go with a different color if you like. So let's say I want to go with purple. Click OK. Here's your S. Similarly, I'm just gonna copy and just make a duplicate of it. So duplicate, here it is. I'm gonna drag it to over here, and I'm just gonna replace it. This is my R. Okay, Shift R, click OK. This is my input D on the left. So this is input D, and I'm actually gonna use it as a toggle. So a toggle would mean you can have basically using it as a switch, so you can turn it on or off. Pulse would mean, you know, and I'll show you. If I choose it as a pulse, then it means if I turn the switch on, it goes on for a second and then goes back to 0. Okay, so I'm gonna do it with toggle right now, but I'll show you later how you can. Okay, all right, so if I go ahead and also, you know, what I could do is I don't need to group it here for now, but that's fine. If you want to do it, all you need to do is go here, click on this right gear at the top right, and then select all, and then say group, and this will be one whole group, right? Okay, both are basically D level sensitive latch. Click OK, and then I'm going to run it now. Okay, all right, now notice here I need to turn my enable on here, turning my enable on, and see your input D is 0, and because that is 0, so Q is 0 and Q naught is LED, yellow LED is turned on. But we know the logic for D level sensitive latch, whenever the enable is high, which is this right here, and let me actually go back and then put a label there too. So I'm just going to duplicate this label right here, go here, duplicate, oops, I'll just drag it from here and put it right here, and then click on this gear and then say ENABLE, that's enable. Changing the font size, color to pink, click OK, and there you go. So all right, so I run the simulation back again. Now I'm going to change my input to D, so D to 1, which is right now 0, and then hope that Q goes to 1. So let's do it. There you go. So every time the enable is high, my Q, which is my bottom LED, goes to whatever the logic is at input D, and because it's 1 right now, so it goes to 1. That means LED lights up, and the top LED, which represents the QN, basically it's going to be the complement of Q. So because Q is 1, Q naught is going to 0. If I go to 0 here, then Q goes to 0, and then QN goes to 1. So that's a very simple way of how you can use digital logic simulator to create latches and flip-flops from there, and then verify the logic. Also, one thing you could do here, and I'm going to show you, is at the bottom there's a timeline right here. Okay, now let's focus. Let me drag this over here. Remember, we are looking at the circuit that I created at the top. So each component has a number, right? So you look at those eight AND gates, they have number like 6, 7. You have NOR gates numbered as 8 and 9. You see those wiring thing right next to LEDs? These basically are, these signals is being monitored, and you can see them in the timeline below. So QN3 that you see at the bottom is actually high right now, and therefore the signal is high. And Q4, which is basically Q, it's 0, and you can see in the timing waveform that it's 0. So I'm going to turn the input D high, and you see the Q in the waveform should go high. So as soon as I turn the input D high, which is the bottom, the input goes high, and therefore Q also goes high, and QN is low. Okay, so if I change the logic back again, make the logic to set to 0 on the input line D, you will notice Q now goes to 0, and then QN is high. So it's actually an awesome way of verifying your circuit using the timing waveform. I hope you enjoyed the video. I shall be back with another one, so stay tuned and don't forget to subscribe to the channel. Thank you for watching. Bye.